So Colin is a Ph.D. candidate at the University of Montana.
Thank you. Thanks very much. Is this green one I don't touch? Oh, okay. The green one's for you. Yeah. Got it. Thank you. Well, thanks for having me, everybody. I'm going to talk about a piece of my dissertation work that's it's a work in progress right now. But I did a... Yes. I did a retrospective study of silvicultural thinning treatments in whitebark pine. And I want to explain what I mean by thinning treatment just so it's clear. This means some type of removal of other species other than whitebark in whitebark stands. And we'll see that means a number of things, especially when you have a retrospective study. Okay. So the goal of these restoration treatments, this is straight out of the range-wide restoration strategy, to reduce competing vegetation, to increase the vigor of surviving trees, and to reduce the likelihood of mountain pine beetle attacks. And admittedly, that's a brief summation of the purpose of treatments. But I want to explain a little bit the ecological thinking and the scientific information that gives impetus to this kind of treatment. Basically, this treatment is in response to what we know about successional dynamics in whitebark pine. This is one of Bob's beautiful diagrams. I don't expect you to go through all of it. but basically, what you need to get from this is that alterations in fire regimes or fire suppression and the introduction of blister-S and increasing mountain pine beetle activity have altered successional dynamics in whitebark pine and might cause some changes. So an advantage of using silvicultural thinning is that you can go in and directly manipulate species composition. You can either stall, reset, or redirect these successional pathways. And this is actually advantageous in fire because fire is a little more random. We've heard a lot today already about whitebark not being that fire resistant. So this is something you can do. You can change the species composition without killing so many whitebarks. But we don't know a whole lot about the effects of these treatments. There often aren't that many resources for monitoring. There is some research out there, but there's not that much. But there's a couple things we do know, and there's a couple things we know that we don't know. Known unknowns. Those are good. So we do have some evidence that radial growth should increase when you remove competing vegetation, and that is an indicator that, of course, it was competing vegetation. We basically know nothing about recruitment dynamics, although theory suggests that we should see an increase in recruitment when you remove competing species. Also, it's mostly unknown what the influence on beetle impacts and blister-S impacts, although we do have some evidence that suggests that there may be some risks associated with doing these kinds of treatments. So my research questions in this study are, what are the effects of thinning on whitebark radial growth, on the recruitment of whitebark and other species? So I'm getting at trying to get at that whole successional dynamics, and whitebark pine mortality. So I found 5 silvicultural restoration treatments in the northern Rocky Mountains and in the one site in the inland Northwest. I selected these because they were at least 5 years old, which is an admittedly arbitrary number, but I wanted to have some kind of baseline for, I figured effects would take a while to show up. These all have different treatment prescriptions, so they're not all the same. I'll go through really quick. One of them's here in Montana, not too far from here, implemented in 2002. There's a mistake right there. I must have looked at this and said, oh, it's open parkland. Well, it is now, but it used to be this dense forest. It was a low component, so this would have been a stand replacing lethal fire regime in that area. The prescription was to remove everything but whitebark. Snowbank Mountain, this is in Idaho. This is more of a daylighting type treatment, so within a radius of whitebark pine, it removed other species. And that was an open park-like type stand, so it wasn't nearly as dense to begin with as the granite butte. And this is on the same mountain, but it's a different treatment implemented 2 years before the other one. And this is a very similar thing where it's essentially a daylighting, but also a very open park-like stand. Whitehawk Mountain is also in Idaho. This is more of a similar to granite butte in the sense that it's a whole area that was treated where all the species were either hurdled or removed, other than whitebark. But it was a mixed open and some closed canopy stand. And then finally, Vinegar Hill in Oregon. This was more like a daylighting treatment as well, except the radius was much bigger than the other ones. So we have a lot of variation in treatments, the type of thinning treatment that's being implemented on the landscape. So my methods at each site, I used a systematic sampling design where I placed plots on a 40-meter grid with a random start. I had 10 tree plots on each unit, and I put control in quotes because really this is an observational study, even though I'm using the language of experiment. I don't know in what ways these areas might have been different, so that is a caveat. But anyway, it's pretty good. It's the best we've got. So 10 tree plots where I sampled all trees, all whitebark trees that are there, including dead ones, and then seedling plots, 20 seedling plots within, and that was to get a bigger area. I tried to select controls that were on the same aspect. There were similar elevation, as close as possible to the actual treatment so that I minimize differences. Okay, and within each plot, I sampled 2 trees per plot for coring, and I took the 2 biggest trees in the 2 largest size classes that were available. I took 2 increment cores from each of those. And I gave each tree a white pine blister rest rating. I used the Forest Service protocol, and then I visually estimated the % crown kill from blister rest. And this is a tree that had some crown kill. And then I also did the competition neighborhood, tree competition neighborhood. And I'm eventually going to use that in analysis to help predict growth response. Okay, so over the whole study, I cored 200 live trees. I'm actually still cross-dating one of the sites, so I'm going to show you the results from 3 sites. This is a very lengthy process, but it's a super important process to do because we really have to make sure that when we're saying that it grew this much in this year, that's really the case. And when you have little tiny rings, and actually this is a pretty good example, there are a lot worse ones. It can be hard, so it takes some time, but it's possible. When I got the tree ring series, I then calculated basal area increment using the diameter and made a calculation of ring width and the diameter of the tree and back calculated the increment. Made the time series for each tree and averaged that between cores to get an average measurement that's hopefully representative of the entire tree growth. And then I took, for analysis, I took the BII, the basal area increment averages, for equal time periods before and after the treatment. And that time period depended on the treatment itself because they all had different implementation times. I counted seedlings of all species, not just whitebark, and I aged the seedlings, or at least attained an estimate of the minimum age of each seedling by counting whorls. And I did this because it's easy to look at a bunch of small, these are all subalpine fir, and assume that they have sprouted up from treatment. But actually a lot of those were quite old. And since my questions are about the effects of treatment, I wanted to make sure that I could remove the seedlings that were older than the treatment. I still counted them, so I have that data. I haven't done anything with it yet. And I also cored every single dead tree that I found in the plot. And I determined the cause of death by looking at characters for blister rust, whether it was rodent chewing or old cankers, and beetle characters, J-shaped galleries, pitch out, frass, etc. And then I cross-dated dead trees to determine the death year. And this is blue stain was another character, and this core clearly shows that. Okay, so my growth analysis, I used a generalized linear model. I predicted basal area increment using unit, so either treatment or control, by time period, before or after treatment, by site. And I included site in there because I knew site was different. I know that the treatments are different, and I have every reason to believe there should be a different effect there. Okay, so some results. This is from 4 of my 5 treatments. Treatment did have an overall effect, but it was a much smaller effect than site alone. So there were site differences that had a bigger effect, and I'll break this down in a minute. And then there was an interaction between unit and site. So that indicates that some of the treatments may have not been as effective, or that there's not as strong as effect there. And this was interesting. I found no significant effect of time period. I think this might be an artifact of the controls not being perfect, and I'll show you what I mean. So here's a look at this data of the average BAI response before and after. Before is the black on the right, and the orange is after. And the first thing that jumps out is the differences between sites. And they're growing so fast at this site that it makes it actually hard to see some of the differences that exist at these other sites. But that's a very simple breakdown of growth response. And what are some of the other things? And I've only begun that analysis and to look into that. And I haven't considered, excuse me, climate yet, but that's probably because it wasn't in the restoration guide. But really, actually, I would like to, if I can. I mean, that might be a temporal thing where I'm limited. But anyhow, here's a look at some of the time series. And this is probably one of my most interesting results, and I want to break this down. So the y-axis is basal area increment, and then year is so this is the time series. The rust-colored here these are trees with some degree of white pine blister rust crown kill, so more than 10% crown kill. And the dotted line is the thin site, or the thinned unit, and the solid line is control, and this is at the Granite Butte site. And the first thing you notice is there's a growth response in both the trees that had crown kill and the other trees, which you would expect. And this is really interesting, that the trees with blister rust responded, and that they had some kind of damage and actually responded. They are still growing slowly, and overall, the average here, right before the treatment, was around 2 centimeters per year, which is pretty low, where it was about twice as much for the uninfected trees. This is not as clear with the other sites. This is Vinegar Hill site. There may be a trend starting to happen here with the not infected trees, but there's no discernible trend here with the blister rust trees. And there's no real discernible trend at this site. And you do see some differences in the control versus thinned, and that just might be differences that have nothing to do with the treatment, but that are just things that I couldn't control for. Also, you notice some really huge error bars here, and that's probably because this is very few trees that actually had crown kill at this site. And in this one, there's no error bars, because there's no error, it's just one tree. So ignore that. But this is interesting, there's not a response here. But again, this was in 2006, maybe I'm just not seeing it yet, and that seems likely, because there was a growth delay in some of the other sites. Okay, so moving on to recruitment. Only one site had enough seedlings of any species to do any kind of analysis on it. So seedlings overall were rare. And unfortunately, whitebark were really rare. There's no significant trend here because there are only a handful of seedlings. This is not significant, although there seems to be a trend of more subalpine fir in the treatment area. And this was significant. There was more lodgepole. Again, though, this is one site. These factors were not controlled for before the treatment. But being on the ground, this confirms with what I saw. A lot of trees cut down, a lot of really young lodgepole coming up, and not so in the closed canopy. But that's consistent with what we know about lodgepole ecology. So no evidence of increasing whitebark recruitment. But again, that might be a time thing. We may just not be seeing it yet. In dead trees, I'm only showing one site here. I have 2 more sites to do. Another site had a bunch of dead trees, but only 2 of them were from the died after the treatment was implemented. 1 in the treatment and 1 in the control, so can't really say anything about that. But Granite Butte, I have 15 dead trees. These were all in the control unit, and this is great. And I'm really excited to look at the other ones because here's really the peak of the mountain pine beetle epidemic. So we had this outbreak happen, and this is where a lot of these trees date to. And they were all killed by mountain pine beetle except for 1. Several of them had blister rust, so they had evidence of blister rust, but they also had evidence of mountain pine beetle. I assumed that those were actually killed by mountain pine beetle. And 3 were purely mountain pine beetle. So that's interesting. None of the treatment trees were killed. But I haven't controlled for density and things like that, so definitely take this with a grain of salt. So in the near future, what I need to do here is I still need to finish cross-dating some live and dead trees, do some more detailed analysis of factors that influence growth response, like the competition, and analyze effects of treatment on whitebark mortality where possible. And I have to look into a little more detail to see if I can pull that out. Okay, so just some conclusions of what I can right now with the data I have. Thinning treatments do seem to increase radial growth, or they can do it at least, but not all treatments do, or at least they don't in a short amount of time. But there was a really big difference in previous density. I mean, the Granite Butte site that showed the really dramatic increase in growth, that was a very dense stand. It was much more dense than any of the others. This is one of the key results that even trees with crown kill from blister rust can respond to thinning treatments. I don't have any evidence really to say anything about recruitment effects for whitebark. There may be some evidence for treatments increasing other species recruitment, and we still don't know about the mitigation of mountain pine beetle caused mortality. There might be something there. All right, well, thank you guys for listening.